This video is a review of simple probability. So I've started with these 8 definitions, which are very important to simple probability, and I've gone ahead and just written them all out because there's not really anything that I need to explain in them. But if you're filling out a review, I recommend that you fill them out and just study over them and make sure you understand what each word means, because there's not much to teach. It's just a definitional thing, so make sure you understand the definitions of these words. So if you are writing them down, go ahead and pause the video and write them down and then hit play when you're finished. And then we're moving on to finding different sets. So I've gone ahead and written these out in advance as well. So set A is a set of all non-negative multiples of 5. So I've gone ahead and written out all the multiples of 5, and then set B is the multiples of 10, and set C is the multiples of 15. So we kind of make it that to line up. So we've gone ahead and written out all of our sets as they're described up here. And then I'm going to go ahead and actually cross out these multiple choice answers because they're all incorrect. So we're going to answer this as if it's not a multiple choice question. So we're looking for what is A union B, which can also be said as A or B. So any number that's in A or in B, we're going to include in A union B. So when I write out A union B, I know I'm going to have to include all the numbers in A. So I'm just going to start by writing all the numbers in A. So we're going to go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And then I also need to make sure I include all the numbers from B. So I have 10, I have that, 20, I have that, 30, 40, and 50. So in this case, I already have all of the numbers in B, so I'm finished. But if I did have another number like 60 or 70 that was in B and wasn't in A, I would add that before I closed it off. So A union B, or A or B, includes all the numbers from A and all of the numbers from B. On number 11, we have the intersection of A and B. So this is the same as A and B. So we're only looking for those numbers that are in A and are also in B. So if we look, we have a 5 in A, but that 5's not in B, so we're not going to include that. But A and B both have a 10, so we'll include the 10. They both have a 20. They both have a 30. They both have a 40. And they both have a 50. So we're going to include those 5 numbers because these 5 numbers are in A and in B. This symbol is read subset. So this is asking, is A a subset of B? Yes or no? So subset means, is every element or every number that's in A also in B? So if we look up here, we're looking at all of our numbers in A. We have all the numbers 5, 10, 15, 20, all the way up to 50. And I'm looking at all of these numbers and seeing, are all of those numbers in B? Well, no, because 5's not in B and 15's not in B. So A is not a subset of B because you have to have not just some of the numbers, but all of the numbers of A in B. And then the next one's asking, is B a subset of C? Okay, so in B I have 10, 20, 30, 40, 50. Are all of those numbers in C? Again, my answer is no, because there's no 10 in here, there's no 20 in here. So they're not all in there. And then just for example's sake, I'm going to add one more of these. What about, is C a subset of A? So if we look at C, C has a 15, a 30, and a 45. So if we look in A has 15 and 30 and 45. So if we were asked, is C a subset of A, the answer would be yes. So there's kind of an example I just added so you could see what it would look like if the answer was yes, it is a subset. Our last symbol for these types of problems is this little c, which stands for complement and means not. So what is A complement is what is not in A. So in order to know that, we need to know our sample space. So I'll go ahead and tell you that your sample space is just the numbers from 1 to 50. All the numbers from 1 to 50. So it's going to take us a while to list A complement because we have to list all the numbers that are not in A. So I'm probably not going to write them all out right now, but I'm going to show you the process. So A has 5, but it doesn't have 1, 2, 3, or 4. Then I would skip 5 because it has 5, and then go to 6, 7, 8, 9, and then skip 10 because A has 10, 11, 12, 13, 14, and then skip 15 because we have 15, go on to 16, and you kind of get the idea. So I would go through and list all of those numbers that are not in set A. All right, so our next section is asking us to develop a sample space. So we're flipping 3 coins, and we're going to let T stand for tails and H stands for heads. So what is the sample space for flipping 3 coins? Well, we learned in our definition section that a sample space is all of the possible outcomes. So I'm going to go ahead and we're going to list all the possible outcomes, everything that could happen if I flipped 3 coins. So I could get a heads, and a heads, and a heads. Or I could get a heads, and then a tails. Or I could get a heads, a tails, and then a heads. Or I could get a tail, and then a head, and then a head. I could also get, oh, let me take the commas out of here so that doesn't confuse you. So tails, heads, heads. Then I could get a tails, and a tails, and a tails. Or I could get a tails, tails, head. Or I could get a tails, heads, tails. Or I could get a heads, tails, tails. So those are all the possible things that could happen if I flip 3 coins. So the first question is, what is the probability that I'll get heads, heads, heads? Well, there's only one heads, heads, heads out of all of our possible outcomes, and we have 8 possible outcomes. So there's a 1/8 chance that you'll roll 3 heads. So then if we take a calculator and do 1 divided by 8, 1 divided by 8 is 0.125. So we can go ahead and round that to 13%. And then number 16 is, what is the probability to get 2 tails? So I'm going to go through and underline any that have 2 tails. So this one doesn't. This one has 2 tails, but not exactly 2 tails, so we're not going to include it. And then this one has 2 tails, 2 tails, 2 tails. So these are the only 3 that have exactly 2 tails. So we're going to say 3 out of our 8 total possibilities, which is 38%. Then we're going to move on to talking about frequency tables in probability. So we're starting right here. We have this nice frequency table about flavor of ice cream, and we're talking to children's, teens, and adults. So the first question is just, what's the probability if we were to pick a random response to this that the person would say chocolate? Well, if we look at the total of our chocolate column, we have 107 people said chocolate out of the 269 totals. So we would do 107 out of 269. And if I enter that into a calculator, I get 0.397%. So we're going to go ahead and round that to 40%. The next question asks, what's the probability if I pick a random response that it would be a teen that answered? Well, total, we surveyed 73 teens out of 269 total people. So we're going to do 73 out of 269. And again, if we do 73 divided by 269, we get 0.27 or 27%. Now we're back to this symbol like we've seen before, and that symbol means and. So this is the probability that the person likes vanilla and is an adult. So if I come to my vanilla column and go down to the adult row, there are 54 adults who also would pick vanilla. So they're adult and vanilla. So I would do 54 out of our total of 269. So 54 divided by 269 rounds to 20%. So then number 20 is the same idea, neither and a teen. So neither and a teen, there's 45 of them. So we have 45 out of 269, which is 17%. So then we move on to a new symbol. It's our union symbol or our or symbol. So this is the probability that the person is a child or they like vanilla. So we're going to look at our total number of children, which is 77, and our total number of people who liked vanilla, which is 92, because we want to include everyone if they're a child or if they like vanilla. The only challenge is if you look at the vanilla column, so we counted all these people, and you look at the children column, we counted this 22 right here twice because we counted in the row and in the column and in the row. So we've got to subtract one of those 22s out, so we make sure we just count it once instead of twice, and then divide it by 269. So if I enter all that in a calculator, 77 plus 92 minus 22, and divide it by 269, I get a 55%. And then 22 is the same idea, teen or chocolate. So I have a total of 73 teens plus 107 who like chocolate. And then minus, if I look at the teens row in the chocolate column, this is the number that got counted twice. And then I divide that by 269. So again, in a calculator, 73 plus 107 minus 12 divided by 269 is a 62%. The next table is talking primarily about conditional probabilities. So if we look at this table, it tells us people who speak Spanish, French, and German, and then boys versus girls. So I'm going to go ahead and do the first two, and I'll actually do 23 and 25, and I'm going to have you try 24 and 26 on your own. So the way that I read this is the probability that the person speaks Spanish given that they're a boy. So given that they're a boy means we know they're a boy already. So we're going to ignore everything else in the chart and just look at the boys. So how many boys do we have? 20. So this kind of gives us our bottom number. We have 20 boys. Now, how many of those boys speak Spanish? 10 of them do. So not the total number of people who speak Spanish, but the boys who speak Spanish. So then we're left with 10 out of 20, which is 50%. So let me show you that thought process one more time on 25. So this is a probability that the person's a girl if we know that they speak French. So we're going to start by how many people speak French? 14 people speak French. Okay, how many of those 14 people are girls? 12 of them. So we have 12 of them are girls out of 14 total. 12 divided by 14 gives me an 86%. So go ahead and try 24 and 26 using that same logic. On to 27 and 28 is reasoning with probability. So we're supposed to decide whether the given method of choosing a winner in the contest is fair. Explain your answer. So the biggest thing to remember is this word fair. In the context of probability means equal probability. The probability is equal for each person to win. So number 27 says, the names of all people entered in the contest are written on pieces of paper and put in a jar. Without looking, one of the names is picked from the jar. So every person has their name in there one time, so they all have the same chance of winning, which makes this fair. They all have the same probability of winning. Number 28 says the person organizing the contest decides to choose a person with a last name starting with S. He then looks at the names of the people who entered the contest and chooses a person whose last name starts with S. Well, immediately I'm going to say that's not fair because they don't have an equal chance of winning. The people whose last name starts with S have a chance. Nobody else does have a chance. So there's no way there's an equal chance because if your name doesn't start with an S, you don't stand a chance at all. So that's kind of the process for thinking through whether or not something is fair or not fair.